Okay. And so you're required to have a calculator. Calculator require. Okay. So you can also view the book online. I prefer you do so because you can also go to the chapters you want to. Let's say we're going to cover chapter um, 1.1, for example. So we can just go to 1.1 and then you can go all the way down to find the homework assignments. Let's say I go to chapter 5, you can click on number chapter 5 over here, trick functions, and then you can click on the part that I cover, like 5.2, for example. And then you can also go to find the homework on the bottom parts of the page. Okay. So homework assignment uh, um, on the bottom of each chapter, bottom of each chapter. So you can always go there and then check. They also provide a solution. Uh, the odd number exercise with a solution, you can always double check that. But usually I will grade based on the even homework assignments. Okay. Very good. If you have questions regarding the finding the homework assignments, just let me know. Okay, it should be at the very bottom of each chapter. So you can always go through it and you can always look at the solution. They do provide a solution, the answer key for chapter one, two, three, four, five. But those are for the odd number uh, questions. Are we good? So we don't have a lot of people today, probably because of the snowstorm that we have on Saturday and Sunday. But hopefully that we can go back to the in person on Wednesday. We'll let you know all of this. Okay, so let me go to the green policy. Okay, the green policy. So homework is a very big part of the grade. So you look at that is this takes 30% of your final grade. So missing out the homework costs you a lot of points. I think I did not. Oh, that's hold on a second. So I'm so sorry about that. So we can also find the syllabus and then which chapter that we have to cover. Chapter 1, Chapter 2, Chapter 3, 4, 5, 6, 7, 8, 10, and Chapter 11. And all of these chapters will be on a final exam. So the first four chapters are going to be on a third exam. I'll let you know what it is. Okay. So, so homework assignments is going to be 30% of the grades. Exam 1 and exam 2 is going to be 20% of the grade. So cover chapter 1 to 4. Okay. I would say 1 to 3 actually. So 1 to 4 is a little too much. Exam 2 is going to be 20% of the grade, and it's going to cover chapter 4 to 6. And then the rest of them will be um, the rest of these is going to be on the final exams like 7, 8, 10, 11. So final exams. It's going to be 30% of the grade. So that's going to cover everything. Okay. So so technically the homework has the same weight as the final exams. So even if you did not do well on the final exam, but if you max out the point for the homework assignments, you're definitely gonna pass the course. Okay. So homework grade have the same weight as the final exams. Of course, the homework is going to be worth more than any of the exam that we have. So it just be considered when you do the homework assignments. And so that's very important that, you guys have to, submit your work and make sure, double check the answers when you submit it. So homework assignments um, will be graded based on like completions, like 50% completion. So and 50% correctness. So that means that if you complete the homework, you get half of the grade. So if you do not complete homework, you don't get half the grade. And then the next 50% of the correctness is based on like some assignment that I choose to grade. I would definitely let you know which assignment will be chosen. Okay, I won't grade the entire homework because that's going to be a little too much. But I will select, let's say, I give you about like 10 different problems or like 15 different problems and choose three problems to grade. Okay. And then the last, and then the other 12 questions that I did not grade, I will just see if you just show me work, how you get it done. And that's pretty much it. I don't really care if you get it right or wrong. But the 50% correctness is based on those questions that I grade. Are we good? Okay, so the next thing that we have to do is that the homework um, must be submitted in PDF file. a single PDF file. So the best app that I can help you, so you might using iPhone apps, using Notes to save as a PDF file, but it might not be clear. So suggestions, app is Adobe Scanner. So that is one of the things that I use it most of the time. It's give you very clear pictures. And also we have Cam Scanner. Those two apps are really, really good. And then I prefer the first one because that one is going to um, take you very little time. You don't have to convert it. Just take like a few photos, and then they just converted the document for you for free. I'm not sure what Cam Scanner. I haven't used it for so long. It might cost like $10 for um for the for the license. It might be a little bit more than that. So, okay. So for the deadline, to the homework deadline is being set every 2 weeks. If we post every week, and the student, we have 2 weeks to complete them. Okay, every week. So what that means is that after they post it, you're going to have 2 weeks to complete the assignments. Some assignments can be like usually 2 weeks. Some assignment may be a little shorter, maybe 1 week and a half. But the minimum time that you should have would be 1 week to complete the assignment. So, and if the student submit late, the homework late, I still count. Okay, until I grade the first. Until I grade it. Okay. After I grade the homework assignments, um, if the students submit, I would take away like 10% penalty. So that there is like 10% penalty. So what that means is after you so let's say after you grade all the homework assignments for all the students. So let's say we have a class of 30 students, like 25 of you submitted on time. And then when I start grading it, you can, I mean, when I finish grading it and then you still haven't submitted, so those 5 students can still submit your homework, but I would take away 10%. Okay. So let's say that homework was like 20 out of 20. So we can only get like maximum 18 out of 20 if you submit it late. I mean, not about being late, like the due date, but about the date that I grade the homework. Okay, I would take away 10%. If you pass the due date, that's perfectly fine. Okay. Are we good? So if the student submit the homework, when you turn in the homework late, but I still haven't graded it, you should be okay. Okay. So no penalty. All right, so this is the very important thing because I don't want to like see a lot of I don't want to see student fail my class. That so if the student forgot to do your homework assignments and then just wait until this at the end of the semester to submit work, submit the homework at the end of the semester, I would take away 20%. So at the end of the semester, like it does not pass the final exams. So if you look at the date that we have for the final exam, I believe it's on May 13th. This is what we have for the course timeline that we're gonna strictly enforce. So the final exam have to be on May 13th. I just want to make myself clear for those dates. So this one is gonna be on May 13th. The second exam, I believe, is on around March 25th. And the first exam will be on uh, February 25th. Are we good? So any question? No? All right, guys. So any questions, any concern? No. Okay,
I
so
have question.
yes, yes.
Do we need to, our computer for this class?
No, you don't have to.
Okay.
Except for today because
Yeah, the snow day.
there's no day. And on usually the PACE community and the PACE call the PACE actually does not allow students to bring a computer, the laptop to class, but I'm okay with this, honestly. So I just want to make sure the student stay focused during the lecture and then they don't do anything else beside the lecture notes. But I feel like, come on, this is the AI, right? This is artificial intelligence. So I believe that all students should have their own laptop or something like this. But during the exam, there are absolutely no electronic devices. And make sure that you bring your calculators, the pen, the pencil, and hopefully that I might assign some, like some privilege for you guys. Maybe I will allow the student to bring a page of notes, like you can memorize the form. You don't have to memorize the formulas, the quadratic equations, quadratic forms, all of this. Okay, that might be the case.
Okay, thank you.
You're very welcome. So, basically, if you do your work, if you submit work, you're gonna get points. No matter how late that you submit your work. So let's say you submit the work after I finish grading it, but I would take away 10%, right? And then remember, homework might be a really big deal if you, let's say, not very confident in math, and then you expect like to do kind of poor on the final exams. So try not to take that 20% penalty. I know some people just like, well, I just want to wait until the end of the semester to submit your work. Remember, the homework was created to assimilate the exam questions. So I believe those are very important to submit on time. But I'm kind of lenient with the deadline because I want to make sure that my student was able to catch up the work. You might have to take care of the other courses, and somehow it's sort of harder than my class. It's completely understandable, but you still have to do your work to get the grades. I have a student who forgot to submit work for the last three homework assignments. So those, a lot of people might think that only three homework, but let's say we only have eight homework for the whole semester. So you're missing three. So you're literally gonna, so, the homework was 30% of the grade. You're missing three out of eight times 20%. You almost make missing like 7.5% of your grade. That's a lot. So if we look at the grade policy, for example, the the scale that we have, like, so 95 to 100 going to be an A, 90 to 94 is A minus, 87 to 89 was B plus, 83 to 86 was B, 80 to 82 was B minus, all of this. Right, if you're missing 7.5%, like missing three out of eight homework, you're basically losing a lot of points. Regardless, all of your grades was like 100 or something. Okay, so all right, I just want to make sure that the students submit the homework. It's a very, very crucial degree. I know some people are just like, well, I just want to do well on the exam. That is not true, right? So the homework, like I said, will be selected from the text that I just showed you. Okay, you can find the homework at the bottom of the page of each chapter, and they do have the odd number solutions. So you can always try some odd number first, and then you're able to solve it. You can compare solutions, and then you get it right. You can try the even numbers. You can do it. Most of the work that it grades will be on the even number assignments. So make sure that you pay more attention to it. I might give you a little trick, like just focus more on the even numbers homework assignments. Okay. Um, are we good? So I just want to talk a little bit about the attendance. It's also very important. Um, Attendance usually not required. However, I have since a lot of people suffer for not having those 3%. So 3% uh, attendance. I mean, not about being required, not being required, but usually if people don't come to my class, I knew it, and I sort of wondering if you why you get a good grade. And yes, all of this. But if you basically come to class every day, so 3% will be added to the final grade. Okay. So that 3% only be fulfilled if the student miss at most three classes, right? Three lectures. Not about three classes. I know that people might miss the exam review, but have to be three lectures. If you're missing three of them, we'll definitely gonna, I mean, three attendance, and you will not get those 3%. I know some of you might underestimate that 3% to your final grade, but look at the grade policy that we have. So 95 to 100 would be an A. So if your grade was 90 and then you add 3%, that doesn't change. However, if your grade was like 84 or something, and then very close to that, and then you take 3%, so that would be 87, or something close to 87. So you might raise your grade from B to B plus. The same thing. If you get the average of B minus was between 80 to 82, for example, and then let's say you got 80, the minimum for like a B minus, but let's say you add 3% of the final grade to that, test and you will get 83, so that would be in B. So some of these will not be applying. So let's say like a C plus, so you get like 75, and that doesn't really help you. But if you get 77, so the C plus will be changed, will be raised to B minus. So most likely that you might get like 1 point markup for your letter grades, and that's become very important in terms of your GPA calculation. So attendance will be recorded every day. So make sure that you come to class. About a final exam, so this is your privilege. This is your thing that you might get like a high grade. So final exams. So all students must take the final exam in order to pass. Of course, taking a final exam does not pass you, but without taking a final exam, basically you have to, I'm going to give you incomplete. You have to make up your final exam. Just don't do that because the makeup final exam um is much, much harder than the in-class exams that you take on May 13. So let's say you decided to take a defer exam on June something during the summer. So the question will be completely different and you do not have time to review. For example, you might forget a lot of stuff, a lot of questions. So even if you might have a similar question that like that, but you forgot about the steps. So if you retake the final exam is basically is like 10 times harder. So I encourage all the students to take the final exam. Um, if the final exam score higher than any of the exams, these any of the exams one and two. So what happening is that I would so the lowest grade either one or two will be dropped. All right. So that sounds a little confusing, right? And replaced by the final exams. So let me just give you some examples. So for example, you have example one. So exam one, you get 65. Exam two is 70 in the final exam. Will be, let's say 78, whatever it is. All right. So what's going on for that is that the third exam will get dropped and it will be replaced by the final exams. So exam one becomes a 78. Exam two still being changed, so it'll be 70 point. And in the final exam, will also be 78. So if the final exam score higher than either exam one and two, one of them will be dropped and replaced by the final. So you're basically going to have a same grade of any of the exam. The lowest grade becomes the final exam grade as well. So meaning that you're going to get more benefit from scoring the higher grades on a final than any either one of these. But of course, it's always better to score high on the first two exams. So we don't want to make we don't know if we going to fail the final or not. So that's might be the case. Okay. But if you have the third exam score higher, In the final exam, for example, you get the first exam was 85, the second exam is 90, and the final exams is only 80. So there's nothing changed, right? So nothing changed in this case. Meaning that all exam score will be kept. So, so the first exam, the second exam, the final exam remain the same. Okay, so that's one of the things that we might have so far. Any question, any concern? So this is like the encouragement for a student who do well on the final exam, but just don't just think of that as a way that you can, like um just study less on either one of these exams. Just try. I would say it's always better to score high on the first two exams because that's easier. This is exam one. Because that's easier to score higher on the final exams. Okay. Yeah, this is from my statistics number. I have students who did really well in the first two exam, and eventually the student's gonna score kind of well on the final exams, or maybe you're gonna have less pressure when you take the final. I have a student who like maybe just not doing too well on the first two exam. They ended up like failing the final exam as well. That's might be the case. I don't know. I mean, it is just a good policy for us and making sure that the you guys are gonna take advantage of this. Okay, I believe that's pretty much it. Oh, we also have the exam correction. This is the last part that we go over today, and then we're gonna go to the lecture, the chapter one quickly. Exam correction. So this one is mandatory. I'm sorry, it's not mandatory. This is optional. I am so sorry. It's not mandatory, right? And um, you always have the right to do and not do it. So this is complete optional. Let us see. Choose to do the exam correction, not to do the exam correction. And all we have to do, let's say, for example, exam one was like 60, right? Okay. So the student lose six, so the student lost 40 points. So now, if you do the exam correction, you can get help from the map tutor in the Learning Commons. There's no penalty for not doing the exam corrections. If you're not choosing this, that's perfectly fine. And if the student do the exam correction, I mean, have to complete, right? Right. I mean, maybe won't make one mistakes. I don't know. I may take away a little bit points, but if do the exam corrections, the student will get back 10 points. We get back 10 points. Okay. So now the new exam points that we have is no longer 60. So the new exam points will be 60 plus 10. So that'd be 70 points. Are we good? And my concern is that I know some student might like score really high uh on the exams. For example, you got 92 and you have a little mistakes that you make on the exam. and then sort of asking if I can do the exam correction or not, I would say yes, you can always do the exam correction, but the number of points that you lose will be 8, and then you can only get like 2 points back. Okay. So remember, in order to do the exam correction, you have to go to see a map tutor in the Learning Commons. So we will have 2 weeks after the exam will return to complete your exam correction work. So you will earn back 25% of your lost points, but not like 100%. Okay. So there's no way that I can give you like 60 plus 40. So in this case, in my case, if you got 60 and then you do the exam correction, you get 10 points back. So that'd be 70. But you have to go to the map tutor to see a map tutor in the Learning Commons to get it done in the center. And then you have to get them signed the paper before you return it to me. I'm gonna change the grades afterwards. Okay. So that's optional. This is not an applications. You're not, you know, you're not losing anything for not doing the exam corrections. But you basically gonna earn some points back if you do that in the center. That's really up to you. All right. So now we're gonna go to chapter 1, will be the function, right? Before that, I just want to let you know about some of the course outlines. So the first chapter you're gonna do with the functions, domain of the function, the range of the function. Okay. And then after that, we're going to learn about the composite function, inverse function, what it means by that. And there's a lot of things going on, and this is how we're going to apply the slope analysis, the linear regressions, and and most of the term that we have for the function. This one is specifically important if you go to take calculus 1 about the chain rules, the inverse function as well. And after that, we're going to go to deal with the piecewise function is one of the very important thing that we're going to do. We're going to do that. And the second thing that we're going to, for the second chapter that we're going to learn about the linear line, equation, and parabola or something like that, which is a quadratic function. So this is going to be a very important part of the lectures because it's going to be on the exam and this application. So this one, you're going to analyze the x and y intercept, the slope, as well as the perpendicular, the parallel lines, its characteristics. So for the parabola, you need to understand about the vertex, quadratic, and some of the application that we need to know. Then we move on to the zero property, like how to find the x-intercepts, y-intercepts. multiplicity of the function. So we're basically dealing with the polynomial functions and behavior, like how the curve looks like. So by completing the pre-calculus that you should know like every single movement of the curve based on its function. And so generally this one is for the polynomial function. How can we write the function given by its intercepts, multiplicity, and behavior, and all of this, okay? And also the asymptotes of the rational function. Okay, so these are basically on the third exams, and then so those three are going to be on the first test. And one. So, and then the roots, right? The root, the zero positive root, and so on and so forth. Root. And we need to know how to use the division and division and long division. And then after that, when it comes to the second exams that we're going to learn about the exponential function, this is one of the things that we have a lot of application along the ways than log functions. It is very important. And its properties and its application. So that one is going to be like a big part of the exams. And we're going to spend a lot of times on it. And topic number 5 going to be on trig, the basic trigs, trigonometry, and how would you understand about the trigonometries, right? So we're going to explain it a lot. It wouldn't be like really, really complicated if you understand it. It's just simply telling us the ratio between um, the side length and an angle, right? So this is why we're going to use sine, cosine, tangents, all of this. They are basically the same thing. I'll let you know. Okay, just hold on a second. So let's say basic trigonometry, tangent, sine, cosines, all of this. Okay. So for each chapter, I want to give you some applications, how we're going to utilize those concept in basic math and basic application. And its application. So this is going to be on a second exam. And then finally, then we're going to go to um, about some trig function, like its periodic functions and all of this. And so this is one part of it, is really, really big chapters. And then second, the 7 are going to be like some trig identity. I just saw trig identity, tricks, how do you solve trig, a trig equation, double angle, triple angles, all of this. Somehow it's not really relevant to the real life situation, but just in case that you have to do like something really, uh, really important projects, but you don't really have a lot of angles that we have, and we don't really know a lot of stuff. And then that might come handy to us to understand some of the half angle and double angles. And afterwards, that we're going to have to learn about the basics, um, like a sine um, and cosides triangle properties in a triangle. And finally, you're going to learn about a sequence. So how useful the sequence is, how we're going to read those, and the logic behind this, like arithmetic sequence, and um, sequence and its sums. Okay, so all of this is going to be included on a final exam. So like I said, there's a lot of like things that we're going to learn, and we definitely going to spend a lot of times on it. But the third exam that we're going to focus on like first 3 chapters. Okay. All right, so let's get started for chapter 1. This is going to be the function. So first we need to define functions, right? What is a function? So a function uh, is denoted by y equal to f of x, right? You have to go like y have to go first, or sometimes have to be the first order. That represent the relationships between x and y, between input and output. So we're basically going to have like a single output. You might have multiple inputs, but there's only one single output. Okay. Okay. So you can have multiple input, but it have to be a single output. And then x cannot, in other words, x cannot repeat. So this one we call a vertical line test. Okay. So let me just draw some like diagram and see what it is. So this is what we have for the inputs, and this is what we have for the outputs. So we can have like one that go with 1, that go with 2. Okay. And then you might have like 2 input that go with 1 output. That's perfectly fine. Okay. So all of them, but you cannot have like one input for 2 different outputs. So that is not a function. So all of them are connected by a function f. Okay. F. So in other words, this is what we have for the x, this is what we have for the y, and then you can just denote that y equal to f of x, okay? Let me just draw a little bit here. So that relation we call a function. I have function f over here. Okay, so there are so many different functions that we have. So there are many different functions. Infinitely many different functions. And not a function, right? And not function. So let me just give you one example, like a few examples. So for example, we have to start with a y. So let's say example 1, you can have y equal to 3x minus 4. So this is what I call the linear function. This is a function. And then you can have example 2. So you can have x squared plus y squared equal to 9. We definitely learn about the circle. I forgot to mention about circle. And yeah, there's a lot of things. So this is a circle equation, but this is not a function. Okay, so why this is not a function? Because if you start with that y squared, right? You start with the y squared. So when you solve for y, you're gonna have like two different x. When you take the square root, when you solve for y, you have two different x. So whenever you go with a y squared, y to the 4, y to the 6, when you have 2x with a single y, or like 5x with a single y, so this is not a function. So I can give you like a visualize things. Let me just draw on the calculator. So we get x squared plus y squared equal to 9. So we can literally check that it doesn't pass the vertical line test. We only know that this is the radius r equal to 3, but it doesn't really pass the test. So this is not a function. Are we good? Okay, so in the later chapter, you might see like some function like that. For example, we have example 3, y equal to like 2 to the x, right? So this is an exponential function, and this is a function. So I know some of you would be wondering how it looks like. So I can sketch the function for you. It starts with y, so it's perfectly okay. So this is a function. So you can draw any vertical lines, and then it's always intersects the function at a single point in any part of it. So meaning that this still be a function. Okay. However, let me show you something that is not a function. Let's say x equal to sine y. So when you look at that, uh, it doesn't start with the y equal to. And so this is not a function. And most likely this is just when you draw a vertical line between them. And apparently that, let's see, it doesn't pass the horizontal line test. I'm sorry, the vertical line test. Okay. So this is not a function. the function. All right. So you should have like, I would recommend you about the love functions. The love function. This is one of the things that I know it's like love function. This is not actually the function, but if you love math, you should know it. This is one of the things that we have like LOVE. So this is what we have for the love. But of course, those are not a function. I mean, the first one is a function. In scatter functions, you have this is the function y equal to 1 over x, but it should be shown on the other side. And x squared plus y squared equal to 9. This is a circle. We just did that. And y equal to absolute value of negative 2x. This is the function. And x equal to negative 3 sine y. This is not a function. It looks like a letter E. It would just only include a very small part of it. It's the love function, right? And then, so remember, the goals of math is to like translate any image into algebra mathematically, algebraically. So even with topology that we're trying to define a subject, right, by algebras, is trying to understand what it is. In fact, you can draw anything on decimals. So draw a cat on decimals, for example. So there are so many of them. You can even draw an Iron Man. That's crazy. Oh my goodness. Yeah, we can generate what it is. Um, yeah, they can generate anything, almost anything. Like even like can also draw trees. This is what we have for decimal at art, so we can build it. And there's a lot of things you can do. For example, I want to draw this. Yeah, we can't. Oh my goodness, that's crazy. You can do a lot of things. You can submit like all of this by graphing calculate draw a cat. Decimal, I don't think that works. But you can literally create any image using the function. That's really cool. But this is not a function, right? Draw a Batman on Desmos. Oh my goodness. They have a map project. That's pretty good. Hmm. Okay, so you don't need a lot of function to draw like the simple, a lot of equation. Yeah. Okay. Anyway, so apparently that we know which one is the function, which one is not a function. So we have fun with it. And now we're going to move up to the next one, which is called domain and range. So the domain basically include all possible values of x. So this one going to be on the x-axis, right? So we read on the x-axis. So in order to find the domains, right? So to find the domain graphically, we need to read from the left to the right, from left to right, and make sure we're gonna draw some horizontal vertical lines, and draw some vertical line to identify it, right? To identify this range. There's So for the domain, we can figure it out quickly, and then the range we're gonna do the same thing. This one's not gonna be on the exam. I just want to let you know include all the possible value of y, which is on the output on the y-axis, on the y-axis, right? So we do the same thing to find the domain, to find the range graphically. We need to read from the bottom to top. I mean, there's nothing wrong that we go from the top to the bottom, but it's better that you start with from the bottom and then go to the top and draw some horizontal line to identify the range. Okay, so let me just show you how to do that. And let's go to content. You can also get all these class summaries on under the course material. So this is what we have for the first chapters. And then let's go through some function. So for example, so we would like to find the domain and range based on this. So the domain, we just have to go from the left to the right. We go from the left to the right, and then you're gonna draw. So this is a solid point, so we have to count. We're gonna draw some vertical line, 1, 2, like something like that, right? So they all intersect the functions. So we're good to go. We do the same thing with draw vertical line, vertical line, vertical line, vertical line, vertical line. However, when you go from the left to the right, we start at 1, so it's going to intersect the point when x equal to 1 and then y equal to 3. But when we start from 1 to 2, for example, right? So there's no curve that this line intersects, okay? So in other words, that we're going to start a domain from -5 to 1. And those are the solid points. So when we have like a solid point, the closed circle, and we have to use the bracket, right? And then when we start from like 1.5, so that it doesn't intersect the function, and when we start from 2, and it's good to go. When you start from 2, um, it doesn't count the endpoint when x equal to 2. Um, but when it's x equal to 2.1, that's perfectly okay. Like 2.5 and 3, 4, and 5. We stop at 5. So in other words, the domain of this function will be from -5 to 1, and then from 2 to 5. Any question? We'll just have to draw some like some vertical line to see if that intersect the function. And then this is how we find the domain of the function graphically. For the range, that we're gonna do the same thing, but so this is where you have to go from the bottom to top. So this one gonna be the range. So we always have to start at the bottom. So we're gonna draw some horizontal line first. So we start from the bottom, -4, no, it doesn't intersect the curve, -3, no, -2, yes, right? So we start the range from -2, and then we go to -1, yes, 0, yes, 1. It doesn't seem to intersect at the point x equal to 2, but it does have the point when x equal to between -1 and 2, so that's perfectly okay, right? And then 2, yes, because even if there's nothing, there's a little gap between 1 and 3 on the range, but it's already fulfilled on the left side of the curve, so it should be okay. 3 and 4, right? So it in other words, the range of the function would start from -2 all the way to 4. There's a gap over here already being filled on this part by this curve. That's perfectly okay. Okay. So even if you see a little gap between 1 and 3 on the y-axis, well, it doesn't mean anything because it already filled from this curve. So the range of the function will be from -2 to 4. That's it. Any question? So the -2 will be open circle. So we have to count this endpoint. We have to use a bracket. And from 4 is also be the solid point. So we have to count 4 as well. So we do the same thing for that question. So let's say if we want to find the domain and range. So the domain, you have to go from the left to the right. And then you have to draw some like vertical axis is whether it's going to intersect the curve. If it doesn't, if it's keep going down, meaning that it's keep going. Okay. Okay, it doesn't seem to be working for some reason. Oh my goodness. So the domain of the function. So we're gonna start from the left to the right, and then have to draw some vertical lines. Okay. And then let's intersect this, right? Even if it doesn't seem. Now, and then 0, yes. When x equal to 1, you look at that. It doesn't intersect this point. It doesn't intersect this point. It doesn't seem to be defined, but you have a little dot right here. That's still we still have to count when x equal to 1, x equal to 2, x equal to 3, x equal to 4. So all of these that we have to count them. So basically, even if there's a little gap at x equal to -1, x equal to 1, it's perfectly fine. It's already have some points over here, some solid points. So we still have to count this. So in other words, the domain of a function would start from -infinity. And then to positive infinity. Okay. When it comes to the negative infinity that we can't use a bracket. We have to use parentheses. Okay. For the range, we do the same thing. For the range, we go from the bottom to top. So we start from negative infinity in this case. So we start here. We draw some horizontal line. Good. This one is good, but this one is not good. So we don't count the point x equal to 2. But every single point that we have on the curve is perfectly okay. So we start from negative infinity up to 2 in parentheses. All right. Any questions? Any concern? Okay. So let's find f of 2, f of negative 1, f of 1. So in order to find f of 2, meaning that when x equals to 2, when the input equal to 2, so we have to go to the right when x equal to 2 right here. The output, we have to look at this, right? The output is going to be on the length, on the height of the y-axis. So we look at back here. So the input going to be the length, and the output going to be the height. So when x equal to 2, the y equal to 1. We do the same thing for f of negative 1 as well. How can we find this point? How can we find the output of x equal to negative 1? So we have to look at the length equal to negative 1, which is right here when x equal to negative 1. So y equal to 1 as well. Okay, this is open. We don't count this point because this is an open circle. So f of negative 1 just 1 by itself. And finally, that we have f of 1. So f of 1, so when x equal to 1, so we have to look at the length equal to 1. So there, this, and that. But none of these first 2 points. So the first 2 points do not satisfy the closed circle. So we don't count these two. We just only count the last one. So when x equal to 1, we don't count these two. We just count the last one when y equal to negative 2. Okay, that is what it is. Any question? Okay, finally, that we gotta go to the main part. This question will be on the binary exams, the third exam of binary exams. To find a domain by a given function. So we no longer find the domain on the graph, but we need to find the domain by given functions. For example, we have the rational function. Okay. So in order to find the domain of a rational function, uh, so the domain makes sure that has a domain we include every point. So let's say we have the all of x equal to p of x over q of x. So remember, you cannot do like anything like 1 over 0. For example, you can use Desmos calculator. So we hit 1 over 0. It's undefined. So the bottom, the denominator cannot be 0. If the q of x equal to 0, that's going to make the function undefined. So we have to exclude those points whenever you see the fractions and make sure that the bottom, the denominator cannot be 0. So q of x cannot be 0 in this case. Okay. So for example, can give you a lot of example for that. So we have a 2x minus 4 over x plus 3. Some of you may ask about what about the numerator? So the numerator is going to give you the 1-intercepts. If you have like something like 0 over 4, for example, we still get 0. Okay, it's just the 1-intercepts. So the top has nothing to do with the domains. So in other words, the domain is the domain for this part. We want to make sure that the bottom cannot be 0. So x plus 3 not equal to 0. So the way that we solve not equal to 0 is the same thing that we solve for the linear equation. We just subtract 3 both sides. And then you can have x is not equal to -3. Okay. Another example for that was f of x of x equal to like x minus 4 over x squared minus plus ax plus 15, for example. So in order to find the domain of this, like we said, we want to make sure that the bottom cannot be 0, so meaning x squared plus ax plus 15 is not equal to 0. Okay. So in that situation, we can also just simply solve for the quadratic equations, just making sure it's not equal to instead of equal to. So we just have to factor this one out. So if you're not good at factor, we can also solve using quadratic formulas. So the 8, you have to look for the sum equal to 8. And then when you multiply two numbers, they have to be equal to 15. So there's the product. Always have to look at the factor, the product instead of the sum. There are infinitely many ways you can get the sum equal to 8. For 15, you can always do it on a calculator. So 15 we divide it by 2, that's not going to work. Divided by 3, so 3 and 5, right? Something like that. So we can always factor this one out in terms of pi and 3 on both sides. So meaning that we can have to rewrite the equation, the inequality, which is x plus 5 times x plus 3 is not equal to 0. Now I'm going to set each of those not equal to 0. We can solve it. So x is not equal to -5. And x is not equal to -3. We just simply change the sign for this. Are we good? All right. Final, and then another form that we have, we call a radical function. So for the radical functions, for example, we can have like the square, like the f of x equal to the square root of q of x or p of x, for example. So whatever inside of the terms, so this one cannot be negative. So p of x is not negative. So meaning that we need to make sure that the p of x have to be greater or equal to 0. So that's the domain of the function. So let me double check for some example. Let's say f of x equal to the square root of 2x minus 4. So we want to inside of the square have so when you do it on a calculator, for example, you take the square root of -3. So undefined, we cannot take a not a negative value when you take the square root. So the function will be undefined. So in other words, you want to make sure for this function, the domain had to be 2x minus 4 is greater or equal to 0. And then we can solve for that. We can plus 4 both sides. So we can have 2x is greater or equal to 4. And then we divide both sides by 2. So meaning that x is had to be greater or equal to 2. You don't have to worry about the interval notations. If you, as long as you can just write me something like that on the finary, on the third exam and finary exam should be good. I will give you full credit for that. Okay. But if you insist on the interval notations, for example, so this can be done between like positive 2 to infinity. And then you have to count the endpoint. Okay. But this is not required as long as you can solve for that. But when you divide it by positive, you don't switch the inequality. But when you, so let's say we have -2, for example, right? And then you have to divide it by -2, for example. And then you have to switch that. You have to switch this because when you divide it by negative, it's not about this one. This one can be either negative, positive, that doesn't matter. But when you divide it by negative, by the coefficients, then we have to switch the inequality. Okay, that's very important. Another example, this is going to be a lot of example that you go after this. I know it's very tired. And let me just go for the function g of x equal to, let's say, 4 minus x over the square root of 3 minus 6x, for example. Okay, so now the domain for this function is kind of different. First, you notice that the term was, on the denominator. So it cannot be 0, right? So you notice the term, the radicand was on the denominator. So it can be 0 first. And then it cannot be negative. So 3 minus 6x cannot be 0 because you cannot do like 1 over 0, like 5 over 0. And this cannot be negative. So it have to be positive, strictly positive. So we do not include equal sign. The equal signs. Okay, so you just have to simply solve for that. And then we subtract 3 both sides. And then we're going to have to cost out -3, cost out 3. And then we're going to have -6x is greater than -3. Now, so what we have here is when you divide it by negative, well, this one, it can be either a negative, positive, it doesn't matter. When you divide it by -6, for example, So we have to switch the inequality. So we no longer have the signs greater than. That will be less than. So we have to switch it immediately right after we switch the sign. So now it turns out to be x less than 2. Are we good? So I'm sorry, x less than -1/2. I'm so sorry. So -3 over -6 is 1 over 2. Less than 1 over 2. So it is strictly like it's strictly less than 1 over 2. So when we write the interval notation, we want to make sure that we don't use the bracket. We have to use the parentheses. So that will be from -infinity up to 1 over 2. And that's it. But you're not required to do this. We just simply write x less than 1/2. We give you full credit for sure. And that's what it is. All right, guys. So it's been very tired today because the first day of class and we have a snow. I'll let you out early. So now when it comes to the attendance, remember attendance is you're gonna, if you have less than 3 absences, you're definitely gonna get 3% added to your final grade. The problem is how we can do the attendance. We have to go to tours. We have to click on quickly attendance. Right, we can do that the same thing. And let me set up first. All right. So all we have to do, yeah, I just gonna do the check-in real quick. And we just have to go to look for so 126. Let me just start checking. All we have to do is just go to tours and quickly attendance. And then you just go and then you're definitely gonna see some of your, like you just have to check in for that. And that's pretty much it. I got 2 people checked in. If you have any concern about the check-in, just let me know. I'm gonna show you again. You can also do it on the phones, but make sure you have to log in the Brightspace. If you don't have the Brightspace account, I have some students who didn't have Brightspace account this morning, and then there's no way I can check in. I can help you on Wednesday after class. If you have any trouble with this, just go to Tools and go to Quickly Attendance. When you click on this, you're definitely going to see, the check-in box pop up, and then you can click check. You just have to hit check, and that's pretty much it. That's very simple. You're going to do that until the end of the semester. Okay, so that's pretty much it. So we're going into the notes. I would also, I'm so sorry. Read the topics. I would also do the lecture notes every class because all of my notes will be done on the pens in the school's laptop. And today, so you can also file the notes under lecture notes. So let's say today is January 26th. I'm gonna upload like 6 or 7 pages of notes in this folder, plus the YouTube lecture videos because we have the Zoom class. Yeah, I would definitely do that. Okay. All right. So once you finish checking, I will see you on Wednesday. If you haven't finished it, that's perfectly fine. Just go back. I will mark all of you present today. Have a wonderful day. Take care.